Okay, last video we talked about, or started talking about what domain and range is, and again, this is review. So once you see a couple, you'll get back into the swing of things. So domain again is your X value. So allowed values for X, so that's your domain. So when you're looking at a particular graph, we have a couple to look at. So we could have one that continues on in both directions. So let's take a line, for example. You just draw any line through the grid. Our domain for this one would look like this. Because there's arrowheads on either end of this graph, it continues on in either direction forever, which means that there is an X value for every point possible. So it continues on forever. And in this case, there's no condition. And it's just domain equals X such that X is an element of real number, so it can be any possible number. Now if we have a graph that has a starting point, so that's the origin, let's go back here. And the graph looks like that. There's X values starting right here on that vertical line. There's no X values to the left here. So it has a starting point right there. So we would label it as the domain equals X such that all my X values are greater than or equal to, and if we assume this is the origin here, 1, 2, 3, 4, 5, so -5, X is an element of real. Okay, so it's saying that all my X values, there are a whole bunch of them, but none of them exist to the left of greater than or equal to -5, or sorry, equal to -5. Finally, what happens if we have a graph that has a starting and an end point? So I'll pick an easy location here. So that's -5, and that's 5. So what happens if we only have a graph that exists here? Well, that means that my lower limit is right there. My upper limit is right there. So the graph only exists in between there. So the graph is not out here. So there are no X values in the green or colored out region. So in this case, my domain then will equal my X value. Always start with the lower limit, okay, your lower limit. So the lower limit here, again, assuming that's the origin there, I picked -5, and that's going to be smaller than the X values, but we can't go past the upper limit, so it's less than or equal to, and again, I think I picked 5, a little tough to read on mine. X is an element of real. Okay, so here's my condition. This tells you where X is, and in the first one I said there is no condition. You'll notice though that the XER is the same in each case, okay? No matter what type of domain you have, there's always the XER. Similarly, you have X such that, and that's that vertical bar, means such that, okay? So there are your three possible domains. Similarly, the three possible ranges, and your range is all possible Y values. So now we're looking at the Y-axis. So you got to kind of discard the X-axis for a sec here. And we're just looking at the Y-axis. So I'm going to use the same graphs, or try to. So we have the line. And now we're looking at the Y values. So on the Y-axis, if I move from the origin, I can see that no matter where I go, because of those arrowheads, there will be a Y value for every part of this graph. So range is equal to Y such that no condition, Y is every possible real number. All right. What would the second one look like? Kind of look like that. So I'll try to draw it the same way. So it kind of looked like that, as long as you're similar. So in this case, I see that there are no Y values below this horizontal line. The graph does not exist in this region, so I need to tell the reader that the only possible Y values start here and go forever along the Y-axis. So range is my Y values such that Y is always greater than or equal to, is it -2? I'm having a hard time reading off the smartboard here. Element of real. Okay, so there's my condition. Here's the condition for y. Okay. And finally, I'm just going to give approximation of what the other one looked like, something like that. The y values, it doesn't go past this horizontal line. It doesn't go past this horizontal line. So the graph doesn't exist out here. So same thing as above, I have a lower limit, that's the smaller y value, and I have an upper limit. So the way you would write that, y such that, always write your lower limit first. Now I'm having a hard time reading off the graph here, so let's say -3, and that's going to be smaller than any y value, but I know that I can't go above, looks like 6. So there's my conditions. Okay, I have to stay inside -3 and 6. If you write lower limit first, so in each case here, I have my lower limit and then upper. Okay, here it was the lower limit. If you do that, you can always write the less than or equal signs in the same direction. And it's just something that works out for you. All right, and there's some practice for you in the homework, and we can check to see how that goes. Okay, some quick examples with state, domain, and range. So here we have, in each case, we're going to write up a domain. We're going to write a range. So domain is your x values. So it's going to go on the x-axis from here to here. So I have a start and an end point. So it looks like it is -5. It's less than or equal to x. So I'm looking, blue line, so I'm looking along the x-axis for my values. Upper limit looks like a 7. X can be anything it wants. For the y, I look for the lowest point. So there's the lowest point. Here's the highest point. And on the y-axis, this gives me my lower and upper. So same process, except I'm looking at the y-axis. Looks like -5, less than or equal to y, and it looks like it goes up to +7. Less than or equal to 7. Y is an element of real. This one I notice that there's arrowheads, so it's continuous, it never ends. So when I'm looking at the x-axis, I don't see an end to it. Okay, it continues in both directions, which means domain is going to be x, such that x is an element of any real number. Similarly with the range, I look up and down the y-axis, it seems to go on forever. So my range then will be y, such that y is an element of real numbers. Last two examples. Again, starting with domain, I always look for my x-axis and I try to see what's happening. Because there's arrowheads, it means it's going to continue, and it's supposed to be a parabolic shape. So when I look at this on the x-axis, because it's a parabolic shape, I know it's spreading out, getting wider and wider. So that means that there is no restriction or conditions for my domain. However, the range is the possible y values. Well, the parabola is never going to go below that point, but it's going to continue forever upward. So that means I do have a condition here, and it's going to say that all my y values are greater than or equal to, now I think it's -2. Again, it's tough for me to read off here. You'll have it a little bit better if you print it off the note. So there's my condition right there. My y values have to be greater than or equal to -2. Similarly, another parabolic example, looking at my x-axis, I'm assuming it to be a parabola, so it's going to get wider. So parabolas and lines are nice because they always have a domain that looks like that. Our range, though, this time, here's our highest point. So where's the y-axis? Over here. And it continues down forever. So my range will be y. Oops, that's a funny looking y. Y such that, and again, tough for me to read, but this time all the y values have to be smaller than +1. Y is still an element of real. All right, so there are your different types of examples, and the examples in the homework are very similar to that. So if you can go work through that. And I have one last quick part to clean up, and we have the first lesson done.